Alright guys, today we're looking at word problems involving scientific notation. You can read through this first one on your own and kind of listen to me maybe as you do it or pause if you need to. First we need to make a change. That should not be a comma there. That should be a decimal point. Okay, did not notice that till after I printed. My fault. Okay, so in this one, basically the summary of it is that you're given the area and volume of the ocean. Okay, and you're supposed to find the average depth. Okay, what you get when you divide volume by area is you get average depth. You don't get a specific depth because the ocean doesn't have consistent depth. I mean, there's places where it's only up on shore. It's we're talking less than 100 feet, near shore, less than 100 feet. But it could be probably much larger than that as well. So we're going to try to figure out what that is. We're going to utilize scientific notation for both these word problems that we have on here. The reason it's so easy to do that is because you are given these numbers in a format that, well, first off, they're really big numbers, number one. And number two, like even the first one, 360.928 million square miles, that's kind of a weird way of saying a number, right? Like 360.928 million square miles. I don't know that you'd ever say a number that way. You would probably just say 360,928,000. So we could use the regular numbers, or we could just use scientific notation. Here's what's really cool about scientific notation. When you follow up a number, any number, with times 10 to the third, you get it in thousands. When you follow up a number with times 10 to the 6th, you get it in millions. And times 10 to the 9th is billions. So what I want you to do is write both of these numbers in scientific notation, pause, and then come back. So hopefully you've done that. 360.928 times 10 to the 6th would be this one. However, that's not scientific notation. Okay, we need to actually, I'm going to round a little bit and make it 3.61 instead of 60928. And we need to make that times 10 to the 7th, 8th, if we want it in scientific notation. Okay, if you recall, if we want to convert this number to scientific notation, that means we're dividing the left portion, I guess, of the number by 10 twice to make it smaller, but that means we need to balance that out on the other side by increasing our exponent by 2, putting 2 more 10s on the other side. This one's a little more straightforward. It's just 1.32 times 10 to the 9th. Okay, now we need to divide our volume by our area. Okay, and what we get is, well, you're not going to be able to do this division in your head. You can do the exponent subtracting in your head. That's going to be times 10 to the first, but you're definitely going to want to use a calculator for dividing 1.32 and 3.61, and you get 0.366 times 10 to the first. Now, the question is, what are our units on this one? Okay, well, we had cubic kilometers divided by square kilometers. Think if you had a fraction of those, like just pretend km was a single variable, like not two variables like k and an m, but one. If you had a cube over a square, it would cancel out just to be to the first, right? So that's what our units are. Our units are kilometers. So are we done? Hopefully you said no. We're not done for two reasons. One, our answer's not in scientific notation, and more importantly, we want to know how many meters that is. We want to know how many meters that is. Okay, so if we want to convert kilometers to meters, what do we have to do? Well, hopefully you said multiply by 1,000, so we're going to multiply by 1,000. And we can use scientific notation. 1,000 is 1 times 10 to the third. So now we get still 0.366 times 10 to the fourth convert that number into scientific notation, and we get 3.66 times 10 to the third meters. So we're talking like about 3,600 meters or so is the average depth. Ask yourself if your answer makes sense. You should always be asking if your answer makes sense. Now, you may not have any idea what the average depth of the ocean is. You could Google it. You could see if we got something close to what it actually is. I Googled it, and it gave me 4,200 meters. So 3,600 meters or so seems close enough to me. That probably means we did an okay job. All right, you need to use scientific notation for this one too, even though it doesn't directly tell you. I'm telling you. See if you can do this one in scientific notation. Try this problem completely on your own, pause, and then come back. Really quick, if you're stuck, you can pause again after this. The key is this word per. If you remember what the word per means, I think you're going to be okay. Okay. Let's use scientific notation. So 3 pounds is 3 times 10 to the 0. Anything to the 0 power is 1. So times 10 to the 0 would just be 3 times 1 or still 3. Okay? That's how many pounds your brain weighs, approximately. And there's about 8 billion neurons, so that's 8 times 10 to the 9th neurons. And the word per means divide. Okay, if you're looking for, the cost per pound is the total cost of something divided by the number of pounds it is. That would give you the cost for an individual pound. So if we're looking for the pounds per neuron, we divide those numbers. 3 over 8 is 0.375. Okay, and 0 minus 9 is times 10 to the negative 9. Again, if you're using scientific notation, you should definitely write your answer in scientific notation. Okay, so we need to increase the left portion of the number by a factor of 10 and decrease this one to back it up. So that's pounds per neuron. That's how much one neuron in your brain weighs approximately. Again, you could kind of Google it to see, did we end up with something that seems reasonably accurate or not. It's not necessary, but you could. Another thing you could just look at is, well, a single neuron, since you can't really see that with the naked eye, it should probably be really small in weight, right? Well, that's a really small number, so hopefully we did okay. The key with these word problems, a lot of times it's just finding those nice words that translate well: per, sum, product, total. Knowing all those different words and how they kind of translate into math can be really helpful. Okay, you don't need to do practice problems for this. We're doing a group activity with this in class on Wednesday. So hopefully you learn something, finish up those WSQs and all that other good stuff.